Alright, so this is going to be our notes on specific heat capacity. We've been kind of trying to take these for a couple days, and I guess we're going to take them when I'm not there. That's fine. I think I can explain this enough and well enough to have you get a good understanding. But the main word in this is heat, and heat, if you remember, is the ability to transfer energy, and it can be through conduction, convection, and radiation, which are all different ways of doing that. Specific heat capacity is really the ability of an object to absorb heat. Some objects absorb heat very easily, and then they change their temperature very quickly. Some objects are much less, or have a greater ability to absorb energy without changing its temperature. We see the definition here. The amount of heat required to raise 1 kilogram of a substance 1 degree Celsius. And then substances are really all different. Some are just increase very quickly, some not so quickly. And really, if we look at this, solids are, so if we looked at a solid, most solids have a low specific heat capacity. So we'll go low. And then liquids, not always true, but many of them are higher. One of the highest is water. If you remember, we looked at a video on this and talking about the ability of water, if you live along the coast of a place, to moderate the climate there, so the temperature doesn't change very much. If you think of where we live, it can be anywhere from 20 above during the day, then go down to 20 below, so a change of 40 degrees, which is great. But if you live in Anchorage and Valdez, it's much different. And then if you look at this equation, though, this is the specific heat capacity, C of P. It equals the energy transferred as heat, and then it's the mass, and then the change of temperature. So, and this one is not going to be as useful. I'm going to show you in a minute. You can write this one down, and you might be able to figure it out, but it's much easier when we compare it to water. And then, so whenever we're measuring specific heat capacity, again, we need to measure the mass of how much we have, the temperature change, and the energy transferred heat. That's kind of hard to do. Like, how do we measure that? Because some readily take on energy, some do not. So this is very hard to do. That's why we kind of rely on a known standard, and then complete or determine specific heat by using a known standard and comparing it to that. Okay, so I'm going to erase this. And then we have calorimetry, which is kind of something we're going to be using in the next couple days. I'm going to move this up. And this is just an experimental procedure used to determine transfer of energy from one substance to another. And we use water with this. And since we know that, we can then say, you know, the Q of W equals the Q of X. So the specific heat capacity really of one equals the specific heat capacity of the other. And we have an equation here for that, Cp, and the W always equals water. So we're just going to compare water. So W is water. And X is the other substance. So if we're comparing it to lead, then we would heat something. Let me just kind of explain how you do this actually. So you have this device. We're going to make one. We're going to use one at first, one that's already made, and then we're going to try to make one of our own. And but we compare the specific heat capacity of water that we know, and we take that, multiply it by the mass of the object, and then the water, and then put it on a scale. That's all you have to do. And then the change in temperature of water. So we'll know the beginning temperature, we'll measure that, and then we will put the object in there and see what the temperature does. And then we're going to do the negative here, so it's the opposite. So heat gained, heat lost is what that's talking about. And that's the one we're usually trying to figure out. Now sometimes we may want to do something else as well and kind of figure out what the temperature is, maybe predict a temperature change, or a specific heat capacity. Or if we knew the specific heat capacity and we knew the temperature change, we could try to figure out the mass. And then we could figure out the mass with the calculation, and then figure out how close we are in our measurements. So really we can figure out the specific heat capacity of the object, we can figure out the mass of the object, or we can figure out the change in temperature. But also what we could do is figure out, because change in temperature is temperature final minus temperature initial. So if we knew the initial temperature, or we knew the final temperature, the initial temperature is often hard to figure out when you're heating something like a piece of metal. We have those little black thermometers, and maybe we'll try them, and then we'll try to figure out the specific heat capacity. Then maybe we'll turn it around and see if we can figure out the initial temperature and see if our calculations are right. But this is really specific heat capacity. It's not too difficult. You have this device. It's just like a can, and it has inside of it has like a little lid. I'll show you this because we're going to be doing this. Then it has like a little divider, and the can goes down inside it. And it uses air as an insulator. So you fill this up with water. It has a hole in the top. Put the thermometer down through here. And you get a starting temperature, whatever that is. You then heat the object, take the lid off, put it in here, put your thermometer back in, stir the water until the temperature stops changing. Then you can figure out any one of those: specific heat capacity of the object, the mass of the object, or the change in temperature of the object. Even you can figure out, if you know the temperature final, you can figure out temperature initial. So we're going to try that, see how it goes. Hopefully these notes kind of helped you. They're pretty basic. We're just trying to use what we know about heat to figure out something we don't know, which is specific heat capacity or any of those other factors. And we use a known, which is the specific heat capacity of water. It's nice to use water because we can cause its temperature to change, and it's pretty easy to measure. So that will do that. Hope that works good for you. And I'll also be doing a problem here for you. So you should be able to do practice C when you're done with this. Let me know if you have any questions, and good luck.